So question 11 in our tutorial 3, we are given figure 3.9 whereby we have a circuit containing a battery, 2 resistors, R1 65 ohm, R2 96 ohm and a switch. So question A, what is the equivalent resistance of the circuit when the switch is open? So class, when the switch is open, we are not connected to R2, whereby the complete circuit is only this one. Okay, I highlight it. So this is the complete circuit when the switch is open. So R2 is not connected. So we can see very obviously the only resistor in the circuit is R1 65 ohm. So our answer for question A number 1, the effective resistance in the circuit will be equal to R1 equal to 65 ohm only. Okay, only R1 is connected. Then question B, number 2. What is the equivalent resistance of the circuit when the switch is closed? What about if the switch is closed? Okay. What about if the switch is closed? So let's say I close the switch. So class, when the switch is closed, we can see that both R1 and R2 both are connected. Okay, so R1 and R2 both are connected to the 9 volt and then they are connected in parallel. They are connected in parallel. See, this is one path and then another resistor sit here. So you can see very obviously. So for the two resistors, they have 2 common legs connected together and they sit at different paths. So they are connected in parallel to each other. So R1 is parallel with R2. So since they are connected in parallel, to find the effective resistance, we are going to use 1 over R. So 1 over R will be 1 over R1 plus 1 over R2. So we will have 1 over 65 plus 1 over 96. So you might pause the video to do the calculations. So we will get our effective resistance will be around 38.8 ohm. So this one will be our answer. Then we proceed to question B. What is the total power delivered to the resistor when the switch is open? So class, when the switch is open, the effective resistance is R1 only, 65 ohm. Then we know that the voltage that supplied to the circuit is 9 ohm. So I want to find the power. So power will be IV or I squared R or V squared over R. So this is the 3 equations we can use to calculate the power. So which one we are going to use depends on the information given. So since we know about the voltage and also the resistance, the value of resistance when the switch is open, so we are going to use the third equation, V squared over R. So we have V squared over R. So the voltage is 9. The total resistance when the switch open is 65. So you may pause the video to do the calculation. So if you do the calculation correctly, it should be 1.25 watts. Okay, and then the second question, what is the total power delivered to the resistor when the switch is closed? When the switch is closed, so we are still using the same equation, V squared over R, but then now the effective resistance will change to 38.8 ohm because when the switch is closed, the both resistor is connected in parallel in the circuit. So the total resistance, effective resistance is 38.8. So now the power will be around 2.09 volts. Okay, so this is how we calculate. So guys, you can see very obviously, when you have resistor connect in parallel, your power, the total power delivered in the circuit will increase. Okay, I repeat, you will notice that from these two calculations, when you have resistor connect in parallel, your power will increase. Then we have solved question 11. So you might try questions 12 to check on your understanding.